Well, welcome back to day 2 of the full system install. As you can see, everything's in place. The guys were here late yesterday to make sure that we were able to get everything kind of buttoned up. When we did our tests yesterday, we discovered that there were some initial faults that were being thrown up by the inverter here. The issue that we're having is that the gateway that Tesla supplies isn't actually capable of handling any more than 4 of the Powerwall 2 batteries. So today we're going to do a series of tests, and the goal for those tests is twofold. We need to be able to get the system to a point where it will island itself, in other words, with the mains power turned off, that the home will be able to charge the batteries off of solar. That's one thing that we need to get done. And the second thing is that the system needs to be able to, with the solar shut off, it needs to be able to charge the batteries. That's important, again, for the energy sovereignty project, because one of the modes of operation will be that when your power is the cheapest, you should be able to manually charge the batteries up to 100% and then slowly discharge them with the coupling to solar to then be able to extend that period of time at which the batteries will be able to power the home. So with that, I'll give you a little bit of background on the 2 main issues that we're having. The first I discussed a little bit, and that was that though Tesla shows on their website that they're capable of handling 9 or 10 of the Powerwall 2 batteries, the reality is that they're certainly not going to be able to do that off of a single gateway. And the amount of batteries that they can then run through any single gateway at this point is unclear. We know currently that we felt that we were hitting a maximum at 6 Powerwalls. But on paper, their gateway should be able to handle, each gateway should be able to handle 6 Powerwalls. So the reality of the situation is that once we did connect all 6, that the gateway itself seemed to be overwhelmed. It was throwing up faults on the inverter. Now, to understand why that is, under a normal operation, when you have solar backfeeding the grid, in the case of the power going down, the grid power going down, the home has to isolate itself. You don't want to have everybody with solar backfeeding the grid and harming people as they're trying to repair the whatever fault there is in the power grid. And so the gatekeeper for that type of a situation is done at the inverter. And so if the power goes down, your entire ability to produce solar goes down. And that's done through some signal handling inside. I won't go into a lot of detail right now. We'll cover that in exhaustive detail later on as we start to go through these systems and how they work. But for now, that's really all you need to know, is that the grid power goes down and you can no longer produce solar. So in this system, we've removed the handling of that and given that to Tesla's gateway. Now that's also the reason why this pipe is so fat here. This conduit actually has to hold the mains not only coming in from the home, but also then after the gateway's done handling it, the full power of those mains coming back out to our panel all fits in this conduit here. That's why that's so large. So what that does now is that when the grid power goes off, it islands the solar system from the grid. This makes sure that no power that we generate makes it back out to the power grid. Well, that brings us back to our inverter. Well, what does our inverter do? Well, in order to make it so that we can still produce solar power, we actually have to trick the inverter into thinking that the power is still on. And the way that we do that is the power for the inverter actually comes from the batteries. And so basically it's viewing the batteries as in the same way that it would normally view the grid power outside. So when the grid power goes out, it doesn't notice. The inverter itself doesn't notice. The gateway does. So then the gateway severs the home. Okay, so that leads us into one possible issue that we're having today, and that is that because the gateway is overwhelmed with having so many batteries to it, that there is that it's knocking out the inverter, that it's not allowing the inverter to pass power from the solar into the batteries. That's possibility number one. Possibility number two is that there's a war going on in the signal handling between how the inverter is viewing the cycles per second of the power that's coming from the batteries, and it's saying, okay, well, wait, there's a fault. I'm not seeing the clean power that I need to see in order for me to continue my operation. Now, is that because we've got too many power walls coming in, or is it simply a signal handling issue that that we're going to have SolarEdge solve at a higher level? We don't know, so that's why we're going to go ahead and having the folks are going to be here shortly. I'm going to move my car out of the way, give them a little more room, and we're going to do some more experiments. So I'm going to close out here, and I will bring this video back in when we have some results to show you. We'll also go over a little bit of what the Tesla app looks like, and how much control Tesla gives you currently over the Powerwall. It isn't much, but it should accomplish the two things that I told you we were looking for: the ability to island the home and the ability to fool it and charge the system up to 100% off grid before then manually restoring it to its normal operation. But stay with us, and I'll come back to you when we're done. All right, well, welcome back to our day 2 recap back here in the studio, relaxing a little bit here, trying to go over all of everything that's happened today, try to form that into something digestible for all you guys. We still have some work to do getting the inverter to cooperate with the system. We're still having some difficulties with that. The situation as it stands right now is that when we turn the mains off and simulate a power failure, the SolarEdge inverter that we have is not capable of maintaining its power, even though it's getting power from the batteries. It's throwing up some kind of a frequency fault. We'll give you more information on that as we get it. The installer, Sunworks, they're on top of it. They've seen this kind of thing before when they've started to hook up several power walls on one gateway, and so they think that they know what's going on with that. Keep you guys informed on how that goes. But what I'd really like to talk to you about is the Tesla app, and how it acts as an interface between the end user, you, the customer, and talk about some interesting conditions that we saw during the testing. So as we move forward in the Energy Sovereignty Project, I'm going to start breaking down the things that we examine in 5 categories, and these categories they're based on what level of problem the situation represents for the end consumer, or non-problem as it may be. So the categories that we're going to use are laudable, understandable, acceptable, unacceptable, and criminal. So I'm using the term criminal in its loosest possible sense, metaphorically. So I'll go through some of these categories as we come across them. You'll kind of understand where I'm going with all of this. So basically, laudable. Those are those elements that are really where the manufacturer has gone above and beyond to try and make the piece of gear, whatever it is that you're working with, whether it's hardware or software, so that it's not only easy to use and easy to understand, but it also shows that they've gone the extra mile to protect the consumer in certain aspects, try and be your best advocate. Much in the way that Tesla is with their cars. They're trying their hardest to try and be the advocate of the owner, and doing their software updates and those kinds of things. That's all in the laudable category. Next we have understandable, and those are elements that might be less than ideal, but they are what they are. They're the result of the state of the art at the time, and those are things that we can then weigh. Do we want to do this based on what we know? And so we go into it with our eyes open, and so then there are those things that are understandable to us. We know why they're there, and we do it. Those are things that we deal with every day. Acceptable, those are those items that are things that need to be addressed, but they're not showstoppers. They're things that we can allow the manufacturer or the installer some time to work out. Good case in point is what we're going through right now with the interface between the Solar Edge inverter and the Powerwalls not being able to power them, that kind of thing. Unacceptable. It's basically just that. It represents a showstopper. Here's something that if the consumer knew ahead of time, that they would not then pursue the endeavor. And then the last is criminal. It isn't to say that the act or that what the device is doing is actually punishable by law. It just means that it's morally reprehensible. It's morally criminal. So, like we said, let's go ahead and start with some of the things that we've identified that are laudable. It's really hard to overemphasize how amazing the technology is where we're seeing it right now. I'm amazed that we're capable of doing this, that people like Tesla and others, LG Chem and others, have actually put the time and effort necessary to engineering these devices to get them out. Solar has advanced by leaps and bounds since the 70s when I saw this stuff as a kid, and now we're talking about rather impressive amounts of energy that these things are capable of producing, and the cost keeps going down. And so those that's to me, I think that's laudable. And so as far as the project goes here, I think that something that needs to be appreciated is the Tesla app. I think that is a benchmark by which all other companies are going to be judged. How well their application allows you to interface with their product on a daily basis. Laudable. The Tesla app seems to be laid out relatively well. The information is pretty easy to understand. There are still some huge issues with it, but we'll go ahead and say that having the application available to the consumer is laudable. So on the understandable category, we encountered in our testing so far that as mass adoption moves forward, there are things that will probably improve as we go, but right now they're an understandable evil. I'll say that the overall size of the system, it's gotten pretty concise. As you can see from the photos, the system is lined up along one wall. It's very easy to imagine that system being installed either on the inside wall of a house or on the outside wall of a house, perhaps in a shed. So it's not, again, it's in the understandable excuse me, in the acceptable, oh no, I'm sorry, in understandable category, where you're able to do it. It's not something that's a showstopper. It's not even something that needs to really be addressed any more than the realization that as technology moves forward, these systems are going to shrink. The systems are going to be more cooperative. And so that was the cooperative element. That was what got me a little bit ahead of myself here. So now we're down to what I feel is acceptable in the system that we have now. Back in the early days of computers, the individual components that you would use to build a computer, there weren't the standardized communication protocols available back in the 90s. So each individual item had to be adjusted so that it would communicate with everything else in the computer. There wasn't this, oh, I'm just going to go ahead and plug this graphics card in, or I'm going to go ahead and plug this printer in. You had to actually go through and tell the system exactly what it had and how it was supposed to deal with it. So we're seeing a similar situation like that with the individual components that we have for our system. Now, it's acceptable so long as eventually we get past those hurdles. So eventually the system will actually operate with the power off. It is what it is right now, and so until the technology marches forward to the point, and it will, where you're able to have a more plug-and-play situation where you're able to mix and match components to create the system that best suits your needs, that all of that will happen, but we're just not quite there yet. But for now, it's acceptable. It's not a showstopper. And then, well, what are some of our what are some of our showstoppers? Well, the one obviously that we've kind of highlighted is digging up the yard. There's nobody that's going to accept that their yard has to be dug up and that they have to double the size of their power utility connection just so that they can use 92% to 96%, maybe even not at all, depending on how you're set up, less energy. That's asinine. That's not going to work. That is absolutely unacceptable. And if somebody were to come to the consumer and say, "Oh yeah, well, and this is going to have to happen," anybody in their right mind would say, "No, I'm gonna wait." And so that's firmly in that unacceptable category. We need to be able to get past that, and we will. So in the unacceptable category, unfortunately, we also have certain aspects of Tesla's application. The application looks really good in the way that it's laid out. It seems to have all of the necessary elements that would be required to manipulate the system and get it to do what you need it to do, but it doesn't. In what I'm seeing so far, it's just simply not allowing you to make the changes. The first thing that's odd, but is maybe in that acceptable category, is that whenever you make a change, the system will wait a half an hour before that change is actually implemented. All right, maybe that's, there's possibly some rationale behind that, so I'm going to let that go. It just makes it very difficult for us to do our testing when we have to make a change, be firm about that change, and say, okay, this is what we're going to do, this is what we expect will happen, let's go ahead and change that, and then wait and examine the result. It's just time consuming, but that part of it's fine. The part that's unacceptable is I haven't done a single thing to that application, with the possible exception of altering the amount that the battery will hold in reserve, that actually does anything as far as the system is concerned. So we'll go over some of this in greater detail once I know more about why. You know, is it something I'm doing wrong? Maybe maybe I have something in the background set incorrectly. I'm going to go ahead and speak with Tesla customer service tonight and try and figure out what it is on my end that I might be missing. But currently, the only thing that I'm able to do is if I set the system to a high rate of reserve, in other words, how much power it will reserve for a potential power outage, then the system will send all of its energy to the battery to try and charge it from solar, right? And if I then lower that down to a threshold of 0, then the battery will operate cooperatively with the home to try and reduce the amount of power that I'm pulling off the grid. So that seems to work. But so far I'm not able to get the system to charge off of grid power like I need it to. So we'll come back to that, and I'll let you know more about what it is that we found. So the last category, criminal. Again, it's tongue-in-cheek. It's metaphoric. It's not to be taken as, oh, you know, there's some legal action that needs to be taken. It simply is identifying those areas where something's not right. Something's not right. And that someone somewhere knows it's not right, but they did it anyway. Right? And so with that, I'm going to show you this. Let's pull this up. Well, so when I first was doing the analysis for the Energy Sovereignty Project, what I noticed was that in the middle of winter, the system was sending power to the grid. Now, at the time, I didn't have any batteries hooked up to the home. Obviously, if I don't have a way to store power locally, that's exactly what's going to happen. If I'm producing more power that day or that moment than I happen to be consuming in the home, the rest of it goes right out the grid. I don't have any way to store it. So that formulated to a great extent, why we even did the Energy Sovereignty Project. Okay, well, we shouldn't be sending any power out the grid in winter. All that power should be going to our batteries. So I naturally assumed that once you have batteries hooked to the system, that's exactly what would happen. Well, explain to me this, what you're seeing here on the screen now. In the middle of winter, for 40 minutes, this was not just a, you know, as the system cycles through, you'll see it do some changes, momentary changes. It'll do something. It'll, you know, power the battery briefly from the grid to, you know, kind of make up for fluctuations, maybe just to kind of keep everything smooth. It will, you know, the power kind of flips around. Some power goes from the solar to the home, some from the solar to the battery, some from the solar to the grid. These kind of little momentary things. But then I noticed, whoop, wait a minute, what's it doing? I watched it do this for 40 minutes. So for 40 minutes, it's sending power to the grid instead of sending it to my batteries. That's a kilowatt hour of energy on a day when I'm only producing 6 kilowatt hours. Am I ever going to regain the value for that went right out into the utility? When I buy that energy back, am I gonna get the same value? Did they record at least the time at which I sent that out to them so that they can value it to a higher extent? I'm hoping so. But even if, why are they doing that? All that power should be going straight into my battery. So that, to me, that's kind of what I mean by when I'm saying that there are certain aspects of this that I'm seeing and that I'll present to you guys that I personally feel is criminal. They shouldn't be doing this. They shouldn't be allowed to do it. And again, I get it that they need to have that capability in the case of an emergency or whatever, if they need to draw some power from the grid to help them out. In the same way that I have a air conditioning system on both of these homes, that both at the studio and at the Energy Sovereignty Project home, that allow our local utility to switch them off or turn down the thermostat. I don't really exactly know how that all works, but anyway, it's a smart system so that in the time of peak demand, they're actually able to then throttle that down so that the grid can remain healthy. And I have no issue with that. That's fine. But I do have an issue with them taking power from my system in the middle of winter when I need it. So that's about it for now. This video's probably already gone a bit long, but if there's any folks out there that have some specific information on what might be going on with the Powerwalls and the and our solar inverter, please give us a shout in the comments and let us know what your own personal experiences have been in trying to get those systems to communicate. And also, if there are folks watching this that have specific questions about some of the things that they've seen us present, if there's something you'd like to hear more about, or a specific experiment that you might like to see as we move forward, very helpful, very helpful. Again, our comments for the Energy Sovereignty Project videos are instrumental in helping us to bring you content that is appropriate, that's in line with what your own projects are and what you want to see. So please like and subscribe, continue to follow along with us, and we'll keep bringing you these as we get them. Again, these videos are going to come through pretty rapid for the next few days as we start doing our tests. We're going to find out a lot of information regarding how the system works. I'm actually going to be headed back over to the Energy Sovereignty Project home right after I shut this video off and get it uploaded, and we'll run some additional tests, and I'll bring that video to you either tomorrow or the next day. So thanks for watching.